we'll be starting with a new chapter, Introduction to Trigonometry. So before moving on to this chapter, first I'll tell you what is the meaning of this word trigonometry. So trigonometry word is composed of three different words. One is tri, gon, metry. So the meaning of tri is three, gon meaning is sides, metry is to measure. So all these three words put together will give us trigonometry. So now it is saying three sides. So a structure which is having three sides is our triangle. So the three-sided structure and the measurement of those sides is called as trigonometry. So we can say trigonometry as a branch of mathematics which deals with the study of the measurement of sides of triangle and also the angles of the triangles. So now we understood about what is trigonometry. So in this chapter there are 6 trigonometric ratios. So in order to deal with this chapter trigonometry, learning about these 6 trigonometric ratios is very much important. So I'll tell you what are those 6 trigonometric ratios. First one is sin theta. Second one is cos theta. Third one is tan theta. Fourth one is secant theta. Fifth one cosecant theta, and the last one is cot theta. So these are the 6 trigonometric ratios which are very much important in order to deal with this chapter. Each and every trigonometric ratios will be having a particular formula which you will be applying further in this chapter. So now we saw what are the 6 different ratios of trigonometry. So we'll start dealing with each and every ratio. Sin theta. Sin theta, the formula for sin theta is opposite by hypotenuse. Next, cos theta. Cos theta can be written as adjacent by hypotenuse. Third one, tan theta. Tan theta is opposite by adjacent. Tan theta can also be written as sin theta by cos theta. The fourth one is cosecant theta. Cosecant theta is ulta of sin theta. It is hypotenuse by opposite. Fifth one is secant theta. Secant theta is ulta of or the reciprocal of cos theta. So it is hypotenuse by adjacent. The last one is cot theta. It is reciprocal of tan theta. So it is adjacent by opposite. We saw tan theta can be written as sin theta by cos theta. Why did I write sin theta by cos theta is because we said tan theta is opposite by adjacent. So what is sin theta? It is opposite by hypotenuse. Here we have a fraction divided by cos theta. Cos theta is adjacent by hypotenuse. So denominators are same. So hypotenuse will get cancelled. Remaining is opposite by adjacent. So same thing we have got. So therefore tan theta can also be written as sin theta by cos theta. Similarly cot theta can be written as cos theta by sin theta. I said about the 6 trigonometric ratios: sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. And also their ratios. Sin theta is opposite by hypotenuse, Cos theta is adjacent by hypotenuse. Tan theta is opposite by adjacent. Similarly, all the 6 trigonometric ratios. Now, we'll take a right angle triangle. Always for right angle triangle, the angle will be 90 degree here. Now consider this triangle as A, B and C. Always this side of a right angle triangle will be called as hypotenuse. And consider, okay, I'll consider two right angle triangles, A, B and C. Even this is having 90 degree because even this is a right angle triangle, even this is a right angle triangle. As I said, this part or this side of a right angle triangle will always be called as hypotenuse. Now, if I consider A as theta, the sign and all the 6 trigonometric ratios will differ. And if I consider C as theta, the ratios will differ. Now, if this is the theta, opposite to theta, this side is called as opposite. And this side which is present next to the theta is called as adjacent. So now, consider this triangle and write the ratio for sin theta. Sin theta's ratio is opposite by hypotenuse. So, for this triangle, opposite is BC and hypotenuse is AC. Next, cos theta, ratio of cos theta is adjacent by hypotenuse. So for this triangle, adjacent is AB by hypotenuse AC. Next, for tan theta, ratio is opposite by adjacent. Opposite is BC, adjacent is AB. For secant theta, ratio is hypotenuse by opposite. Hypotenuse is AC and opposite is BC. For secant theta, the ratio is hypotenuse by adjacent. Hypotenuse is AC and adjacent is AB. For cot theta, the ratio is adjacent by opposite. Adjacent is AB, opposite is BC. So all these ratios are for first triangle. Next, consider this triangle. Now here we are considering theta as C. Here the theta was considered as A, angle A. So for this triangle we are considering C as theta, angle C as theta. Now we'll write for sin theta. Sin theta is opposite by hypotenuse. So now here opposite to the theta is this side. So this will be called as opposite. And the side which is next to theta is this one. So this will be called as adjacent. So we can see that it all depends upon the theta angle which you are taking. Which angle is theta? Based on that, your ratios will be changing. Ratio values will be changing. So for sin theta, opposite by hypotenuse. Opposite for this triangle is AB. Hypotenuse is AC. Cos theta, adjacent BC by hypotenuse AC. Tan theta, opposite is AB, adjacent is BC. Cosecant theta, hypotenuse AC by opposite AB. Secant theta, hypotenuse AC, adjacent BC. Cot theta, adjacent BC by opposite AB. So this is the ratios for second triangle. So we can see that sin theta cos theta, the ratios values have been changed when you change the theta's place. So now let us move on to the exercise 11.1, first exercise of the chapter trigonometry. The first question under exercise 11.1 says that in the triangle ABC, right angled at B, AB is given as 24 centimeter, BC is given as 7 centimeter, and we are supposed to find out sin A cos A and sin C cos C. So in this first question, we have two sub questions. So first we will solve the first sub question, that is sin A cos A. Now they are saying in the question that there is a right angled triangle and it is right angled at B. So 90 degree is named as B, and here we will be writing A and C. And it is given that AB is 24 centimeter, BC is 7 centimeter. AC value we don't know. We are supposed to find out AC value. For finding out AC value, we will be applying Pythagoras formula. So according to Pythagoras formula, hypotenuse AC square will be equal to the sum of other two sides. The other two sides are AB square, BC square. So this is our Pythagoras formula. AC value we don't know, so we'll keep AC square as it is. AB is 24. Since square is there here, we'll write the whole square, plus BC. BC value is 7, the whole square. So A square is equal to 24, the whole square is 576, plus 7 square is 49. Now A square is equal to 576 plus 49 is 625. Now this square will be sending it this side. Whenever the square crosses the equal sign and comes to another side, it will change into the square root. So the square root of 625 is 25 centimeter. So now we found out the value of AC. So the value of the side AC is 25 centimeter. Now we are supposed to find out sin A and cos A. Sin A, they are saying that the theta is A. Here in theta place we have A. So our angle will be here. Sin A, what is the sine ratio? It is opposite by hypotenuse. Now our angle is here. So for this theta, this is opposite and this side will be adjacent. So for sin A, opposite value is 7, hypotenuse is 25. Next, for cos A, the ratio is adjacent by hypotenuse. Adjacent is 24, hypotenuse is 25. Now this is the answer for the first sub question, sin A and cos A. So next, second sub question. Second sub question is sin C and cos C. Now let us find out sin C. So now for the same triangle, only the theta will change. Here the theta will be for C. The values remain always same. Sine ratio is opposite by hypotenuse. For this theta, where it is arranged at C, this will be opposite and this will be adjacent. So opposite value for sin C is 24, hypotenuse is 25. Cos C is adjacent by hypotenuse. Adjacent is 7 and hypotenuse is 25. So this solves our first question. So now let us move on to the second question. Second question says that in the given figure, find tan P minus cot R. So now they have given a diagram, a right angle triangle, where the PQ value is 12 centimeter, PR value is 13 centimeter, and QR value we don't know. Similarly, as we found out a side in the first question, similarly we will be using Pythagoras formula for finding out this value, and then we will find out tan P and cot R. Now, so our first step is to find out what is the value of this QR. Now, first we will put Pythagoras formula. PR square equal to PQ square plus QR square. Now, PR value is 13 square, PQ is 12 square plus QR value we don't know, we'll keep it as it is. 13 square is 169, 12 square is 144 plus QR square. Now we need the value of QR square, so we'll send this 144 this side. So whenever a number is crossing equal sign, it will change its sign and it will come. So here if nothing is there means always plus sign is there. So now when plus 144 is crossing equal sign and coming to another sign, it becomes minus 144 is equal to QR square. 169 minus 144, the value is 25 is equal to QR square. Now this square, when it crosses equal sign and comes this side, it becomes square root of 25. Square root of 25 is 5. So our QR value is, so now we found out the QR value. Next our work is to find out tan P and cot R value. They are saying tan P. Look for the theta. They are saying it is P. So our angle will be, our theta will be over P. Now, what is the ratio for tan? It is opposite by adjacent. Now, theta is near angle P. So this angle opposite is QR. QR is 5. Adjacent is PQ, which is 12. Now we found out tan P. Next, we are supposed to find out cot R. Cot R ratio is reciprocal of tan. So adjacent by opposite. They say it is R. So now our theta place will change. It will be here. Now for this theta, where it is angled at angle R, adjacent is 5, opposite is PQ, that is 12. Now we found out tan P and cot R value. Now they have asked us to find out or determine tan P minus cot R. So now tan P minus cot R. Value of tan P is 5 by 12 minus cot R. Cot R value is 5 by 12. So both are same. So how 1 minus 1 is 0 when both are same. Similarly 5 by 12 minus 5 by 12 will also be 0. So our value of tan P minus cot R is 0. So this finishes our second sum of exercise 11.1.